Hi, good evening. Uh, am I audible?
Yes, sir.
Yeah. So maybe we'll wait for a couple of minutes to see if a few more students can join and then we'll get started. Before getting started, let me introduce myself. So I am Durga Prasad. So I'll be the teaching assistant for these live sessions that will be organized every Saturday till the end of your course. So the main object of these sessions is to help you clarify some of any of the doubts that you have while solving your assignments. I'll also take up a couple of problems so that we can have some discussions on the subjective concepts as well in addition to numerical problems. So I hope you have already gone through the lecture videos for this week. So before I get started, so if you have any queries, we can discuss them first, and then maybe I can initiate some questions and then we can have further discussions. Feel free to unmute yourself, or you can also type in the chat box. That's up to you, whichever way you prefer. Uh, Sorry, I don't know Bengali, and anyways, I think English is better for communication so that most of the students or participants can actually relate to with that. Since the course is also being taught in the same language, so I'll prefer English. But you can see if any of the other participants, you can kind of chat with them or whatever you can do with them. So if there is any other participant who can kind of explain you in Bengali, then that would be fine with me. I guess there are no questions from you. So do you have any queries or something from this week's lecture? I think this is just an introduction, so maybe I'll start some discussion, so then maybe you can interact and then we'll get to know. I hope my screen is visible. So are you trying to say something, someone? Okay, I guess not. So if you do not have anything to say, can you kindly mute yourself? Sorry, but I just want to inform you that all these lectures are going to be recorded. So in the interest of everyone, these lectures will be in English. So I may not be able to teach in another language. If you have any challenge with language, maybe I'll I'll let you know by next week. So what can be done in this? Okay, since there are no other questions from you, maybe I'll start the discussion. Okay, I think people are still joining. We'll wait in a couple of minutes. Okay, so I just want to initiate some discussion. So this week most of the lectures starts about only the basics. So the first concept that's being taught is about continuum. So let's say each of the cross here denotes a particular particle, and I want to say measure density. Density is essentially the number of particles per unit volume. So which of these 4 scenarios would you consider to be a continuum and which of them is not? So what essentially is continuum? Okay, first of all, is the question clear? Okay, maybe let me ask a little more different question. So let's say we have, so how do I measure density? So I'll try to kind of partition into some areas, and then from there I'll try to estimate how many number of particles are there in that particular area. Let's say I've let's say I've divided something in like this, and then I'll try to measure the number of particles in each place and each volume. If I calculate the density in each of these volumes and then take an average value of them and see if the average value is close to the value in the original interrogation area, and then I'll say it follows the approximation. Otherwise you would say that it is not following that particular approximation. So with that in mind, so which of these options will follow that particular assumption? So I guess this is too obvious, so maybe you are not answering because it's too obvious. Okay, I'll take it like that. So let me ask you a slightly different question. So maybe we'll go to the next question, then maybe we'll kind of have it a little different. Let's say we have 2 tanks, tank A and tank B. Both are kind of a rigid one, but then in the tank B you have a piston here. This is a piston, let's assume it is massless or something, and then it is exposed to atmosphere. Well, the other one is a closed tank, so it's a fixed volume kind of one. This connecting tube, whatever is there, let's assume that it is of negligible volume. I have a valve here. So now what I do is I open the valve slightly so that the gas flows from tank A to tank B, and then this piston gradually rises upwards. My objective is to find the final pressure of the whatever gas is inside both tank A and tank B combined together. So how will I consider my system for this scenario? Can I consider just tank A as my system? So which of these would you think will be the right system? One, two, or three? I would just like to reiterate the fact that this is not a regular class session. So the main object of these sessions is to help you solve your assignment problems, and kind of if you have any doubts, I would like to clarify them. So don't treat this as a regular class session, as a kind of I will be delivering some lecture and you will be kind of listening to that. Whole tank considered as a system. I would want to have a discussion so that I can kind of understand if you have understood the concepts correctly or not, and then accordingly give assignments for the next week. Okay, so one of you have texted saying whole tank will be considered as a system. Okay, now let me ask this question. So if you consider the whole tank as a system, what would be the, like, we also discussed in this week about the state of a system. So what is the state of a system? Like every state is kind of fixed by a certain number of properties. So what would be the properties of this system that you have considered? So now you said you consider tank A plus tank B as your system. So what are the properties of those systems? Like how will you fix the state of that system? Pressure, temperature, and volume. Okay, here tank A and tank B volume is fixed, but how will you define the pressure here? So I have two different pressures. Like if I consider tank A plus tank B as one big system, then I have two different pressures within the same thing. So is it possible, like is it allowed to have something like that in a system? The left portion has a pressure PA and the right portion has a pressure PB, and PB will be equal to atmosphere if the piston is massless. So I think that is clear. So we are saying slowly, why is this particular thing important? We'll get back to that once reversible processes start. For now, let's assume that without this entire discussion is not valid. So for now, we assume that this piston is always in equilibrium. So the pressure in the tank B is always equal to the atmospheric pressure. So PB is atmospheric pressure. Since gas has to flow from A to B, PA should be higher than PB. So if I consider A plus B as my system, can I have a scenario of having different pressures within the same system? Is that allowed? Okay, sure. So what I am trying to ask is, here you have two tanks A and B. Tank A is at a higher pressure PA and tank B is kind of connected to the atmosphere through a massless piston. So pressure in tank B will be equal to atmospheric pressure. So now when I open the valve slowly, gas flows from tank A to tank B. So the pressures will keep on changing in tank A. However, the pressure will be constant inside tank B and that will be equal to atmospheric pressure. So now the question is, one of you have texted saying I will consider my whole tank as a system. So now the question is, can a system have different pressures at different points? Let's say if it is allowed, let's say you can have a system with different pressures at different points, then how will I fix the state of that particular system? Is my question clear? Yes. So which of these do you think is true then? So if I have a system with different pressures at different points, then how will I fix the system with pressure, temperature and volume? And second, if this is not possible, then what other possible systems can I consider? So if you say yes, you can explain why and how you can fix the state. If you say no, tell me any other possible combination of defining my system. And since one of you have already commented that, let's say I'll also want to just make a brief comment on that. So you mentioned you will use pressure, temperature and volume. Do I need to know all the three values to fix the state of the system? I'm kind of reiterating this little because this might be little helpful for your assignment problem as well. Since the assignments are graded, I cannot discuss the assignments directly until the solutions are out. So I'll kind of discuss slightly relevant concepts but not exactly the assignment questions. So maybe you can say, so maybe you can answer this question. So yes or no? So how many of you think that it is an S, that a system can have different pressures at different points? Or maybe let me put it differently. So if a system has different pressures at different points, can I say that it is not a continuum? When a piston changes the positions from initial to final, then there is change in pressure and volume. If you consider tank A plus tank B as your system, then you are saying from initial to final there will be a change in pressure and volume. So but what about temperature? One of your friends has commented about temperature. So what happens to temperature? So will the temperature remain constant, or will it also change, or we don't know anything about it? Temperature constant. Okay. So one of you said temperature is constant. So why do you think temperature is constant? So you are assuming temperature is constant, or you are saying temperature will remain constant? Okay, before even coming to temperature, let's first answer this question. So can a system have different pressures at different points? So because you have the first answer that you told me is I'll consider tank A plus tank B as my system, then a portion of it has a pressure PA and another portion has a pressure PB. So is that kind of a description allowed to be called as a system? From whatever the way we define the system to be. I guess the question is clear, and I don't think you have any problem with the language also now. So I think my pace is also kind of okay. So does the question make sense? It's like, were you able to understand what I was trying to ask, or should I rephrase it? Okay. So initially when I asked to determine the final pressure, the question is which one of these will you consider as a system? So one of you told that I'll consider tank A plus tank B as my system. So if you consider in that scenario, then portion of the system has a pressure PA and another portion has pressure PB. So can a system have something like that? Different pressures at different points. That is the first question. If you say it is an S, if it can have different pressures at different points, then how will you fix the state of the system? Or is it possible or is it not possible? And if you say it is not possible, like it cannot have different pressures at different points, then the combination of the system that you described is not correct, and you can suggest me any other alternative. Is it clear now? Is the question clear now, or should I kind of have to rephrase it in some other way? Or maybe I'll kind of ask you a slightly different way. So maybe I'll put it this way. What is the difference between continuum and uniform? Are they both the same? So when we defined continuum, we were saying that you take a certain number of particles, like you have a certain domain, and then you split into certain parts, and then you kind of measure that property in that particular part, and that remains the same. So if you go even lower, then you might end up in scenarios where you might not have particles at all, so you should not be seeing at that scale. So you keep on increasing your scale to a certain level at which this kind of thing diminishes. So when I was saying this, so here if you see any of these things, if my interrogation area is the total square that you see here, then the density will be one particular value. If I reduce my interrogation area to a little squares like this and then take an average, then I'll have a different value of density. So if I keep on changing my interrogation area size, the density will vary. So there will be a certain point after which this becomes constant, and that is the scale we are calling as continuum. Now the question is, how is it different from uniformity? So if continuum approximation is valid, does it mean that the properties are uniform throughout the particular domain? Okay, so all of you are silent. So is the question not clear, or it doesn't make any sense, or you are just thinking over it? So which one of these should I assume from you now? Okay. So can I assume that you are clear with the concept of continuum? A simple yes in the chat box would be sufficient for me. So if you are fine with continuum, then maybe I'll ask what this particular problem is about. We are actually discussing, like the point that I am trying to make here is about the uniformity in the properties, not about the motion of the particles. So say you have a certain domain, say you are sitting in a room and then you want to measure the pressure at each and every point inside the room, or say then you put some, say you have a thermometer and you want to measure temperature at different points in the room. So you measure at the bottom, top and middle of the rooms, and then you see the values are kind of same. If the temperature sensor is giving same values of temperature throughout the room, then you call it to be uniform temperature distribution. So that is the uniformity that I am speaking about. It's not about the particle motion or something. So if you consider the same room, when I mean continuum, it is like saying when I am taking these samples, if I go to the micro level, then at that level, if you try to measure temperature, it might be something different than the ones that you are measuring at an average value that you are doing at the macroscopic scale. So there will be a scale after which this average value kind of makes sense, that will not fluctuate, and that is a scale that we are calling as continuum. So is the difference between these two clear? Forget about uniform. Is continuum clear? Or are there any queries in continuum? To those of you who are kind of mathematical, if I kind of plot it, say if I am measuring density in this particular question, so density is my y-axis, and let's say I am measuring my interrogation volume. or interrogation area is the area of this little square. This little square area is what I am calling del V. So what would happen if I consider very small values of delta V, then the density could be either 0 or it could be very high. Sometimes like it could be any value that will be completely random. But if I keep on increasing my interrogation area, so from 1 square to if I increase it to this much, so 2 by 2, so from 1 by 1 to if I increase it to 2 by 2, then it will kind of a little bit stable. But if I increase it to full level, then it will be completely stable. So it will kind of oscillate, and after certain volume of my interrogation area, it becomes kind of a constant. So this is my continuum regime. So is this part clear? Then maybe I'll kind of relate how this is different from uniform. And then we'll get back to the question that we were discussing. So are we all on the same page with what continuum is? If you do not reply, I'll assume that something is missing. So please reply something, that if you understand something, you can just type Y, S or something, so that I can proceed. Or if you are not comfortable with something, please let me know. I'll try to understand what went wrong. It's okay. The delta V here is not specific volume. This is the interrogation area that I am speaking of. So, or you can call it my sampling thing. So essentially, if this is my entire domain, this big square is my entire domain. Now I want to measure density. Density is mass by volume. So I need to fix a certain volume, and then I have to count the total number of particles in it, and then I'll multiply with the mass of each particle, and then from there I can calculate my density. So that is how I do it. So I can now the volume that I have to consider in my density can be anything. So I can consider the full square, count the total number of particles, and then divide by the total volume. That would be one way to define it. So let's say rho 1 is total number of particles in the total volume by total volume. Or I can split it into small regions like the one that I have shown here and consider only this small one. So if you consider this one, the area of this, the number of particles in it is only 1, and its volume is total volume by 9. Plus, similarly I can take this one, so there are 2 particles and its volume is V by 9, and so on, and take an average value of all of them. I can further divide it into even smaller regions, or I can kind of do it in this way, this 2 by 2 area, and then do it different ways. So this delta V here is this volume, V by 9. So if my interrogation area is 1 by 9, then the density will be a different value than the value that you get here. So for example, if you consider this case, here the density, if you measure in this one, it will be, let's say each one particular square has a volume of 1 unit. So the total volume is 9 units. So this one will have a density of 1, this one will have a density of 2, this one will have a density of 2, this one will have a density of 1. So have different densities. When you take a mean of all these ones, you will get a density of around, let's say 2.3 or 4. Now if I measure the total number of particles in the total domain and then divide by 9, so let's say you have around 25 particles here, so this will come to around 2.6 or 2.7. So this and these values will be different. This is just one particular value of delta V. Now you can again subdivide it into even smaller parts and then measure number of particles. Then you will actually end up in some scenarios where some areas will not even have any particles, like the one in this. So if you subdivide it into like this, there are no particles here. So density here will be 0. So maybe this is much easier to calculate. So here you have 0, 0, here you have 1, here you have 3, 1 and 1. So if you take average of all of these, so you have 1 plus 1, this is my total mean average. Now if you see the actual density, like if you are sampling only in this particular small thing, here density is 0. Though the mean density is 2 by 3, but at this particular region it is 0. So this delta V refers to this particular small volume. Like, are you considering this volume, or are you considering this entire volume, or if you are considering only this volume, like depending on whatever area you are considering. So that is this delta V. It is not a specific volume. So is it clear now, or there any questions in this? Or maybe I should ask you a question then. So let's say I want to consider 2 by 2 areas. What would be the mean density if I consider 2 by 2 ones, all possible 2 by 2 ones, let's say in this fourth option? So what will be the density? So how many 2 by 2 squares are possible in this 3 by 3 square? If you take this 2 by 2, you have 0. If you take this 2 by 2, you have 1 by 4. If you take this 2 by 2, you have 2 by 4, that is 1 by 2. And if you take this 2 by 2, you have 5 by 4. So if you take average of all of these, so that is giving me a value of 0.5. So if my interrogation volume is a 2 by 2 one, then I am getting a density of 0.5. But if it was something like 1 by 1 that I have considered, or let's say 3 by 3, then I am getting something like 0.67. So the density is kind of different in different ones. This will keep changing until you reach a certain point, after which it will not change with respect to this particular point at which this transition happens, and this second regime is what we are calling continuum. Is this clear now? Maybe I should have asked this question in the beginning. So how many of you, I just wanted to know the background of you guys. So how many of you are undergraduate, and how many of you are from like mechanical and different branches? Can you kind of just text it, so that in the next sessions I can kind of give examples in this particular direction. So maybe you can test whether you are undergrad or you graduated, and then maybe you can say which branch you are. You can just type in the chat box in the meantime. Okay, now that this is clear, so now you understood what continuum is. So now my next question is, if I am saying that continuum approximation is valid, does it mean that the property has to be uniform throughout the domain? What is uniform? Uniform is like you have a domain, something like this. I measure at different points the value of that particular property, and if the value is same at all the points, then I call it to be uniform. So now, if continuum is valid, does it mean that it has to be uniform? So now continuum is clear. I think you understood what uniform is. So now the question is, are both of them the same or different? Okay, maybe I should ask. So is the question clear? So you understood what continuum is and you understood what uniform property means. So are both the same? Or if they are not the same, then maybe you can briefly say what's the difference between them. So like, can I have non-uniformity when continuum is satisfied? Yeah, please type in your response, and at the same time can also type in your uh, background as well as like which branch you are or something like that, whether undergrad or you have already graduated. I've seen very few of you responded in the discussion forum. And if you are willing to actually attend for an exam, you can type in that as well. The questions for assignment and the final exam are going to be similar. They are not going to be dependent on what we are discussing here. Like you won't be having any subjective questions, most of them will be MCQ, and they will be very similar to what the assignment questions are. So if you are planning to take the exam as well. Coming back here. So can I have non-uniformity in continuum? Yeah, feel free to unmute yourself. This session is essentially for discussion. And okay, now that most of you have joined, maybe I'll kind of introduce myself a little again. So I am Durga Prasad, so I am a PhD student. So I'll be the teaching assistant for this course, for these online sessions. The discussion forum will be maintained by two other TAs, which they posted their details as well in the forum as well. So me along with another TA will be conducting the online sessions. So my sessions will be on every Saturday till the end of your course. So we'll be having around 13 sessions for this particular course. And the main objective of these sessions is to kind of help you to solve your assignment questions. So if you have any queries when you are going through the lecture videos or something, you can ask them here so we can discuss them in live instead of posting them on the discussion forum. If I am not able to explain something, or maybe the way that I explain is something not clear, please feel free to let me know, and then I'll kind of pitch in the instructor or someone so that they can explain you and help clear your doubts. So now coming back, so if you do not answer, I'll assume that something is not clear. So I would kind of encourage you to come up and say what is not clear. Is something wrong with the question? Something doesn't make sense to you? Or so what was it that is preventing you from typing in here? BTech second year mechanical. Good. You also BTech second year mechanical. Okay. So hope you guys will be taking exam as well. Okay, so coming back to where we were. So you understood what continuum is, you understood what uniform is. So does one imply the other? So can I have a scenario where continuum is existing, but then uniformity is not present? So let's just take your room as an example. So in your room itself, you can have different temperatures and different zones, but each particular zone can be considered as a separate continuum. There will be some kind of a gradient from one particular zone to another zone. So this and this has no implication. The continuum is still valid, and then you can still have non-uniformity within the continuum. So if this is a scenario, now getting back to our original question, so one of you have told that you will consider tank A plus tank B as your total system. So in that scenario, if I want to fix the state of my system, a single pressure alone is not sufficient because I have two different pressures inside the same tank. So I need to kind of specify what the function of pressure is, as I need to kind of come up with another variable that will tell me whether you are measuring within tank A or tank B, and then I have to measure pressure in both tank A and tank B separately. Only then I can fix the state of this particular system that you have mentioned. Okay, now comes, maybe I can ask you the obvious question. Can I consider tank A alone as my system? So by definition, you wouldn't consider tank A alone as your system because mass is escaping through the valve. The same applies for tank B as well. The only problem comes when you take both tank A and tank B together is fixing that state requires you to specify pressure as like a non-uniform pressure instead of having a single pressure value. Now in the last part of the lecture videos of this particular week, you have seen something called a process. So what is a process? Or maybe even before that, you mentioned three properties before: pressure, temperature and volume, and one of you have mentioned that temperature is constant. So maybe that person can kind of elaborate it a little. So how is it that you assume the temperature is constant, like you assumed it, or you have some reasoning behind that? So I am currently doing PhD now in IIT Madras. So the person who kind of messages this is still in the meeting, and can you kind of say, or is there anyone who kind of believe that temperature is constant, or any other option maybe? So with whatever information I have given here, will you be able to find the final pressure? So if I give you the value of initial pressure, like PA and PB I have given you, atmospheric pressure I have given you. Let's say you told you need volume. Say I told you what the initial volume is, and I kind of gave you what the initial volume of both tanks A and B are. So will you be able to find the final pressure? It's like what information is needed to solve this problem? Maybe I'll put it a little easy for you. So let's say you told that you will need pressure, volume, temperature, and similarly for the tank B, these are required to specify the state. That is what you have mentioned. So from this state you are kind of moving to a new state. If you open high pressure to low pressure area, flow, so low area piston move upward, so I think temperature not change. Can you elaborate it a little? So you're saying if the valve is open from high pressure to low pressure area, so area piston will move upward, okay. I think temperature does not change. So basically you are trying to say that it is flowing from high pressure to low pressure, so your pressure will decrease and volume will increase, so that temperature will not change. Is that something that you are trying to say? Okay. Okay, to those of you who are more mathematical, maybe I should put it in this way so that you can also kind of interact now. So let's say my initial pressure, like initial state is fixed by only with these three properties, pressure, volume and temperature of tank A and tank B. We already decided that we need to kind of specify both tank A and tank B separately, otherwise system won't be fixed. So I need 6 properties to define my system initially and at the final state as well. So if I know my initial state, all of these are knowns, so these will be my unknowns. So I have 6 unknowns. So how can I solve this system? So like what are the 6 equations that I have that can help me to solve this system? So what is given in the question? Like what are the equations that can help me to solve for the 6 unknowns? It's like all these 6 unknowns. So what is given in the problem? It's like if I want to solve this, I have to put it mathematically. So what is given in the problem? Just convert it into math. So before even trying to solve the problem, you should be able to kind of be in a situation whether the given information is sufficient to solve it or not. So if it is sufficient, you will go ahead. If not, then you will understand that you cannot solve this particular problem. So one way is to just list down what are all the unknowns, and then you list down all the equations. If number of equations is equal to number of unknowns, then you say that you can solve this with whatever information is given. If it is not equal, if you have lesser number of equations, then solution is not unique. And then you can ask us that the question is wrong, or maybe you can ask us to give more information. So what are the equations here to solve this problem? My objective is to find the final state, all these 6 ones. So you kind of texted me before that these are the state variables that I will be requiring. These are the properties that I need to measure to fix my state. Is the question clear now? So do I know anything about PA prime? Integration PDV? No, let's not go into that. Integration PDV is something that will come later. So my question is essentially you have 6 unknowns, so I need at least 6 equations. Now let's say even if you do integration PDV, what do you know about, like how will you do the integration? You don't even know what P is. Like you cannot proceed further, right? The problem is now you have to kind of formulate it so that you can solve it. So I have 6 unknowns. So what is information that is given in the question that I can use? So do I know anything about PA prime? Do I know anything about what the final pressure is? So what will happen at the final state? So when will the flow stop? So this is a valve here. So now flow is happening from here to here. So when will the flow stop? So if both the pressures are equal on either side of the valve, then no flow will happen. Like he was mentioning before, it flows from high pressure to low pressure. So at finally you should have PA prime should be equal to PB prime. Yes, you should have both of them to be equal, then no flow will happen. That is one equation. And do I know anything about PB prime? Do I know anything about the pressure inside the tank P? So this, as I was saying before, if you consider it as a massless piston, or even if you have mass here, the pressure here should be always equal to atmospheric pressure plus this. Why is that? So if I consider a free body diagram for that piston, let's say if piston has a mass, you don't even have to consider massless, so you have mg and then you have atmospheric pressure times area, the force acting on it, and then you have the inside gas pressure times this. So if I write this, so what will be my equation? So if, or maybe we'll put it upwards, if my coordinate axis is this way, and I've already mentioned that it is a very slow process. So when you have a very slow process, this term goes to 0. So my internal gas pressure this is atmosphere, it will be something, and atmosphere is not changing and piston mass is not changing, so internal gas pressure is constant. So your next equation will be Pb bar equal to some constant, and that constant will depend on atmosphere. Say if you have a massless piston, and in that scenario this will be equal to atmospheric pressure, or essentially if you have, even though mass is there, if it can be neglected with respect to atmospheric pressure, this will be equal to atmospheric pressure. So this is your second equation. So what other equations do I have? Maybe you can see the diagram and then you can say what other equations do I have here? So now I have two equations for pressure. I can find Pb prime and Pa prime. So now, and there are two other variables, volume and temperature. So do I know anything about volume here? So can I say anything about Va prime and Vb prime? Va is constant because we have a rigid container, so Va prime equal to Va. So I have one more equation. So what about Vb prime? So this is continuously expanding, like this piston is continuously moving upwards. So it is movable, so you cannot say Vp prime equal to constant, so you don't have any equation for Vp prime here. So I just have 3 equations as of now, but then I have 6 unknowns. So what are the other 3 equations that I should be using? Like, what other information do I need to solve this problem? So let's say if I assume it to be an ideal gas. If I assume it to be an ideal gas, then I can use the state equation. So I can say like, okay, maybe I should ask this question. Yeah, so can I write it like this? Is this correct? Yes. Okay, anyone who says no? Okay, maybe, okay, if you see here in tank A, so when the valve is open, gas is continuously flowing from tank A to tank B. So don't you think that mass will be continuously changing inside tank A? So this relation is valid. PAVA is whatever mass is there inside A. R is anyway universal gas constant, and then you have TA. The same equation applies for the second case. Okay. Similarly for the second one. So this won't be equal, right? So without taking mass into account, you won't be able to say they are equal. Like they are kind of connected through a valve through which some flow is happening. So mass is continuously getting transferred from tank A to tank B. So you should take into account that effect as well. So now I think it comes to clear. So now you have what? So previously we thought only 3 were sufficient. So as you mentioned, now it is clear that mass also needs to be accounted. So now the state will be fixed by how many variables? You need to know initial mass as well, which means I need to know final mass also to fix the current state. So let's say, so now I have 2 more unknowns. So maybe from 6 it changed it to 8. So let's take, okay, now what am I left with? I have 3 equations and 8 unknowns. So let's say I'll use ideal gas law. So ideal gas law is like, how many equations will I have here? So I'll have PA prime, VA prime. And similarly for the next second one. So I have 5 equations and 8 unknowns. So still this is not solvable. I need 3 more equations. What other information do I have? So we have used ideal gas law. This is because of, sorry?
So please continue.
Yeah, you are saying something. Please go ahead. This is meant to be an interaction session. Yeah.
Actually,
Oh, you are saying this is not mass, it's number of moles or something? Okay, or you are saying basically the total number of molecules inside the total system is constant?
Yes, sir.
Yeah, so that kind of boils down to saying initial mass and final mass is the same for the total system. That is system definition itself. So Ma plus Mb is Ma prime plus Mb prime. Sixth equation. I have 6 equations and then I need 2 more equations. What are the other 2 equations? So this is basically, the first one comes from like the valve thing. This comes from assuming that it is a very slow process and reversible, and this is because the problem is defined to have a rigid container. And these two are ideal gas law, and this is the definition of system. So what other information is required to solve this problem? I need 2 more equations. So what other information is there? And just to be a little clear, so in the ideal gas equation, I'm not sure, like some of you might have been come with a different convention. So the R that we are referring to here has the units of joule per kg Kelvin, not per mole. So R value will be different from 8.314. So this is a universal gas constant. This is different from the R that we are using here. This is with respect to joule per kg Kelvin, and this is something that will change from gas to gas. So for air, so essentially the relation, maybe I should use a different notation. So the R bar is 8.314. So the R here will be R bar by molecular weight. So in case of air, you can take it to be 287 or 297 or something, depending on whatever molecular weight you are considering. Okay, coming back here, so what are the other 2 equations that are available? Like, what are the other 2 equations to kind of solve this system? Okay. Okay, maybe can I say that insufficient information? So I kind of deliberately did not give you all the information. Now here comes the next part. So one of you have commented previously, I think he left the call, or I'm not sure if he's still in the meeting. So he kind of mentioned that the temperature is constant. So if you assume temperature is constant, then that will be your next equation. That is Ta will be equal to Ta prime and Tb will be equal to Tb prime. These will be the 2 additional equations, so 7 and 8, and you will be able to solve the system. But this is something that has to be explicitly provided to you. You cannot assume that it is a constant temperature process. So basically the question needs to tell you something about what the heat transfer rate is also. Just by here we haven't specified what is happening at the boundaries. Like, you consider tank A plus tank B to be your system, and this particular piston will only tell you what the work is happening, how the work is happening, but nowhere in the question I mentioned about heat transfer. So only if I specify, if I tell you clearly that either you maintain a constant temperature, or like I need to kind of specify that it is an isothermal process, or let's say adiabatic process, or I should somehow give you an information about the heat transfer, only then it becomes, you will have those 2 additional equations and you will be able to solve the problem. Yes, I think it is clear. So now maybe let us change it a little. Now let's say if you want to, instead of solving it using a system approach or something, if you want to use a control volume, so I can consider tank A as my control volume. In control volume, mass flow rate is allowed. It's like mass can flow out of the boundary. So if I consider only tank A as my control volume, and let's say it is an isothermal process, will you be able to find the final pressure So I'm saying that I'll consider this as my control volume, only tank A. Mass can flow in or out of the control volume. So will you be able to, like, and I told you that it is an isothermal process. So is that valid? Like I'm saying you that temperature is constant. So will you be able to solve it, or is something inconsistent? So if you're not answering, I'll assume that something is wrong in the way I phrased the question. So what I'm trying to ask is, I have my tank A, and some gas is flowing out of it. The pressure here, initial pressure is known, final pressure is also known, because the valve has to stop, and that should be equal to Pb prime, and Pb prime should be equal to atmospheric pressure that we got from the equilibrium. And this is a constant volume tank. So can I determine Ta, if I tell you that Ta equals to Ta prime, is the state fixed? So like, is everything consistent, or is something wrong in this?
So if tank is releasing mass, how it is temperature is the constant?
Yeah, that's exactly the kind of thing that I'm trying to ask. So if Ta equal to Ta prime, and this is continuously releasing gas, so is this possible or not?
Possible, sir.
Not possible. Is anyone who kind of says it's possible? So basically volume is also constant. So what is it that is changing here, as the tank is continuously releasing gas?
Continuously releasing gas means maybe volume is also constant.
Volume is constant, pressure is decreasing,
Pressure is decreasing.
temperature, so I'm saying temperature is constant. Let's say temperature is constant, so what could happen? So if you take your ideal gas law, no, R value is a universal, like it only depends on your, yeah, so that is not going to change. So what is there in your ideal gas law?
Pv is equal to m.
So we told V is constant, temperature is constant, yeah. So the mass is what that is changing. So you can have like the relation between Pa and Pa prime will give you the relation between the initial mass and final mass in the tank. So only if I tell you that Ta equal to Ta prime, then you will come to this relation and you will be able to find what the final mass is. So if I do not tell you this particular equation, you will not be able to solve this problem. Either I need to tell what is Ta, like the relation between Ta and Ta prime. If I say it is an adiabatic process, then you will accordingly use that particular relation and then come up with what the value of Ta prime will be. So this is something that I need to specify additionally, in addition to whatever is already provided in the question. So something that relates to heat transfer has to be provided. Okay, now coming back here, what is the next part of the question? Okay, control volume we have covered, system we have covered. So properties, what properties are required to fix the state of the system? So there are these, we need these 8 properties to fix the state of the system. So I think this part is clear. Is there anyone who says that something else? Are these 8 properties sufficient to fix the state, or I can use a subset of them to kind of fix the state of my system? Fine. So the initial part that we were discussing, that you can have this part I think is also clear. So we can have a system which have different pressures at different points. So if you consider tank A plus tank B as your system, portion of it has a pressure PA and other portion has pressure PB, which are different from each other. So this is called non-uniformity and it has nothing to do with continuum. I think that part is also clear. Is there anyone who has doubts in that? Okay. So now comes the next part is straightforward. So now you have fixed these properties. So which of them are intensive and which of them are extensive?
Sir, one second, please. Sir, please ask my answer, sir.
So which of these 8 properties are intensive and which of them are extensive? So there are only basically 4 properties here. It's like that other 2 are coming because of the discontinuity at the valve. So out of these 4, which of them are intensive and which of them are extensive?
Temperature and pressure is intensive technically.
And the other 2 are extensive properties. Volume only extensive.
Volume.
Volume is extensive, fine. Mass will also be extensive, right? Your mass will keep on increasing. So mass is extensive and pressure and temperature are intensive properties. So yeah, now comes the last part. The last part of the lecture video also talks about what process is. So you have for different state, the transition from one state to another state. If you represent it on a graph, it is called like that is the process. So if I want to draw it graphically, how will I draw it? So what are the coordinates that I will be choosing? So before drawing the graph, let's say I want to draw a 2D graph. So okay, first of all, can I use a 2D graph in the first place to describe this particular process?
Sir, PV.
Okay, if you want to use PV. So what is my initial state? I just want to kind of come back here again to say you that there is a discontinuity here because of the valve. So if you want to fix the state of this entire system, you need to specify 2 pressures. Keeping that in mind, how will you kind of draw it on the graph?
Option.
Sorry, options.
Okay, so pressure, sir.
Slightly decrease the pressure. Okay, let's say initially the pressure will be say at PA, there is no PB, and initially say volume is something. Your volume keeps on increasing, pressure keeps on decreasing. I will plot something like this. Only for the tank A. So you can see here that, so okay, is this valid first of all? The total volume of the system, tank A plus tank B, is continuously increasing and the pressure is decreasing. Is this valid? Is volume constant? Okay. One of you told that volume is constant. So for tank A, volume is constant. Pressure keeps on decreasing. So should I draw something like this? Okay, arrow is also important. So PA to, let's say this is PA prime. So you are saying tank A is a rigid container, so I'll draw something like this. I think that's what you put in the comment box. Okay, now let me ask you a question. So when we define the state of the system, like we are kind of discussing not about the control volume. So if you consider this control volume, for this control volume you can say volume is constant and then your pressure keeps on decreasing. But we kind of decided that when we want to use the system approach, we will use tank A plus tank B, not tank A alone. So when I have my system defined as tank A plus tank B, my volume will keep on increasing, right? Because the piston is keep on moving upwards, so volume will keep on increasing. It's not constant. Only tank A has a constant volume. Yeah, volume will increase. So but what about pressure? Pressure inside tank B is constant. In tank A, it keeps on decreasing. Yeah, pressure is constant in tank B, but if you see tank A, the final pressure, the pressure will be proportional to mass. Your mass keeps on decreasing, your pressure will keep on decreasing till the equilibrium is achieved between tank A and tank B. This will keep on happening. So pressure is not constant in tank A. So I cannot draw a straight line, something like this also. Maybe something like this. I cannot draw something like this, that pressure is constant. So this is also not correct. I cannot draw this because pressure is constant in tank B. So what do I do? Any suggestions? Yeah, that's exactly the question. So if you consider tank A plus tank B as your system and then you want to draw it on a diagram. Okay, let's for now simplify the case. Let's say if I only consider tank A as my system, is that allowed? By definition, tank A cannot be considered as system because mass is continuously flowing out of it. In a system, mass should not cross the boundary. Until and unless I consider tank A plus tank B, I do not have a system defined. Okay, the point that I want to bring here is with just these two coordinates, you would not be able to draw anything. That's just because of the valve that is giving you the discontinuity, you will not be able to draw anything. So unless you provide another dimension which kind of tells you the distinction between tank A and tank B, you will not be able to draw this. So, or maybe something like if I put some x coordinate or something, the pressure will be something like in the tank A it will be constant initially some value, tank B it will be atmospheric pressure. Now if I draw volume also as a function of x, this x will be the third thing. So up to here it is tank A and up to here it is tank B, something like this. Tank A volume is something, tank B volume initially is something. So what is happening is this tank pressure will keep on reducing, so it will move to some new line, but tank B pressure is constant, so it will remain the same. Similarly, tank A volume is constant, so this will remain the same, but tank B volume will keep on increasing, so it will kind of move up. As the process goes on, this keeps on coming down and this keeps on increasing. So just one graph won't be sufficient, you need to kind of represent it in two different states with a new variable something, some x or some other variable that will kind of help you to distinguish between what is tank A and what is tank B. All of this is happening because of the discontinuity that is at the valve. Is this part clear or are there any questions? Clear. Okay. I just want, this is the last part of it. It starts about temperature measurement. So I just briefly gave you a small kind of a discussion one. So I just want to hear what you say about it. So you have some thermometer that is calibrated at only two temperatures, 0 Celsius and 100 Celsius. And then you use that particular thermometer to measure at 40 degrees centigrade. But when you compare this with another kind of thermometer, you see that there is a difference between both of these values. So what could be the reasons? So maybe I can kind of tell you in a slightly different way. So you have a resistance thermometer is something like, you know, resistance increases with temperature or resistance changes with temperature. So for every temperature you can have a unique value of resistance. So if you put that resistor in some Wheatstone's bridge or something, you will be able to find the resistance value, and this resistance value can be mapped to the corresponding temperature. This is one kind of thermometer. The other kind of thermometer is a mercury in glass thermometer, where you have the differential expansion of mercury inside the glass, and that volume expansion will be kind of correlated with your temperature. This is another way of measuring temperature. So now with these two, I calibrated both of them at 0 and 100 degrees centigrade, but however, when I measured at 40 degrees centigrade, their values are not matching. So what could be the reason? Or is it not possible at all? So if I calibrated 0 and 100, does it always mean that it has to be same everywhere throughout the interval? Okay, first of all, is the question clear?
Clear, sir.
Yes. Okay, how do you attempt such kind of question then? So where do you start with?
Please start with mercury thermometer.
Okay, let's say you have mercury thermometer. So in mercury in glass thermometer, what I have volume expansion, or basically let's say length related with temperature. So how is length related with temperature? Length is some function of temperature. So what is the principle in mercury in glass thermometer? It's like you have, say, you say initial length is L naught, or volume or length. Let's say area of cross section is not changing, and L is your initial length. You know, its temperature is changing. So at L naught you have, at T naught you have a length L naught. At particular temperature T you have a different length L, and then you know the coefficient of thermal expansion of that particular substance. Then you relate L with L naught, something like this. So now whenever you know the value of L, you will be able to find the particular value of T if you know L naught and T naught. So if I write this equation in terms of temperature, so basically I need to find the temperature given the value of length. So how will I? It's just a matter of rearrangement. So L is my input, L naught, alpha and T naught are something that needs to be specified. So alpha is a material property, so this is not going to change. So how do I fix this relation? So can I write this equation something like some constant times L plus some other constant? Basically your A will be 1 by alpha L naught, and your B will be T naught minus 1 by alpha. So this is a linear relation. In order to fix this linear relation, I just need these two constants A and B. So how many equations do I need in order to get these two constants? It's basically you have two unknowns, so you need two equations. So that is why if I calibrate it at say two temperatures, say 0 degrees Celsius and 100 degrees Celsius, I'll have two equations, T0 and T100. So T0 is something. So I'll calculate the length at T0, and I'll have T100. I'll calculate it say L100. I'll use these two equations and find A and B. As long as this particular equation is valid, which is kind of derived from this particular physical relation, that you are assuming that it is within this design. Just two equations, so two unknowns, so just two calibration points are sufficient. So if in a scenario you observe that after measuring at these 2 points, and if you measure at some other intermediate point it is not matching, it means your fundamental assumption here is something wrong. So basically something like it is not following this linear expansion. Instead, you might have a quadratic expansion or something else. In those scenarios, you might need to come up with a relation which is not linear. Instead, you'll have some other coefficients like something like, let's say you have a quadratic relation. If you have the relation like this, then you have 3 unknowns to be determined, which means you need at least 3 equations, which means you need to come up with at least 3 calibration points. So is this clear? So if you are saying something is not matching at an intermediate range in which you calibrated, it means the relation could be nonlinear. Is this part clear?
Yes, sir.
I think these are the questions that I have for this week, and most of them are kind of covering, most of the assignment questions are dealing with your ideal gas equation. So are there any other specific queries that you have in this week from the lecture videos or from the assignment questions? You are not clear about the question. Since they are graded assignments, I cannot discuss the solutions, but if you have any difficulty with understanding a question, I can help on that. Yeah, if there are no questions, then maybe we can end the session for today. We can meet next week as well. Or if you have something to discuss, we can discuss as well. So we have around 30 minutes left, so around 25 minutes. So if you have something to discuss, we can discuss. Otherwise, feel free to leave the session.
Okay, sir. We are ready to meet.
Okay, sure. Thank you. Thank you. Okay, we'll meet next week then. Thank you all for joining. It is available in the description as well. So if you have any queries, that you can also post in the discussion forum. TA will be there to assist you over there as well. Thank you for joining. Okay, we'll meet next week then.